All right, today we're diving into a cosmic mystery that's literally hiding in plain sight. We're talking about a ghostly halo, something so huge it appears larger than the moon in our sky, but it's completely invisible. And you know what? It's making us rethink some of the fundamental physics of our entire galaxy. So, right at the center of this whole puzzle is an object called Geminga. It's hanging out in the constellation Gemini, about 800 light years away, which is pretty much our next-door neighbor in cosmic terms. But the weird part is, Geminga is surrounded by this enormous, invisible cloud of high-energy particles that, well, it just shouldn't be there. And scientists are really scratching their heads trying to figure out why.
So what exactly is Geminga? It's a pulsar. Think of it as the super-dense, spinning corpse of a massive star that went supernova a long, long time ago. And for decades, this stellar remnant has been the #1 suspect in a cosmic whodunit, all thanks to this invisible, high-energy glow that just surrounds it.
Okay, let's look at the case file here. Geminga, or PSR B0633+1746, if you want to get technical, is about 342,000 years old. And get this, it spins on its axis every 237 milliseconds. That's incredibly fast. For its entire life, it's been like a cosmic sprinkler, just flinging a constant stream of high-energy particles out into space. And that is where our story really gets interesting.
You know, scientists had a hunch for a long time that Geminga was sitting inside a cloud of these particles, but they couldn't actually prove it. The first real clue didn't come from a normal telescope seeing light, but from an observatory that detected something totally invisible to our eyes, a huge flood of powerful gamma rays. And this discovery didn't happen overnight. It took more than a decade to piece it all together. It started in 2007, when the Milagro Observatory got the very first hint. Then, 10 years later, the Hawk Observatory confirmed it was real and measured just how massive it was. Finally, in 2023, the H.E.S.S. telescopes gave us our best look yet, proving this ghostly gamma-ray halo was definitely not some kind of illusion. But, you know, confirming the halo existed only made the mystery deeper. According to the physics we know, a cloud of high-energy particles shouldn't just sit there. It should have scattered into the cosmos a long time ago. So what in the world was holding it all together? To really get what's going on, we need to talk about something called diffusion. Think about it like this. If you light a match, the smoke spreads out in the room, right? In the vastness of space, high-energy particles are supposed to do the same thing, spread out and disperse pretty quickly. That's just the standard model for how this stuff works. But around Geminga, that's not what's happening at all. The particles are barely moving. Instead of spreading out, it's like they're trapped in some kind of cosmic molasses, just diffusing at an incredibly slow crawl. It completely defies what we expected to see. And here's the kicker. The measurements show that the particles around Geminga are diffusing up to 100 times slower than the galactic average. This was the smoking gun. Absolute proof that the space around this pulsar is fundamentally different from what we see almost everywhere else. So this slow-motion escape became the central mystery. The top theory was pretty straightforward. There must be a magnetic field acting like a cage, trapping all these particles. To prove it, scientists knew they needed to find another clue, and they had a pretty good idea of what they were looking for. The logic here was actually really elegant. We know the halo is made of superfast electrons. Now, when electrons like these get caught and spun around by a magnetic field, they radiate energy as X-rays. It's a process called synchrotron emission. So the plan was simple. Find those X-rays, measure how bright they are, and boom, you can calculate the strength of the magnetic cage. So the investigation turned to two of our most powerful X-ray eyes in the sky, the XMM Newton and NuSTAR space telescopes. A team of scientists started digging through mountains of their archive data, launching the most sensitive search ever for the faint X-ray glow that just had to be there. After all that painstaking analysis, combing through all that data, the verdict was in, and it was complete and utter silence. The telescopes found no significant X-ray emission from the halo. Nada. Zip. This chart really shows you just how dramatic that result was. On one side, you have what our models predicted we should see, a clear X-ray signal. But on the other side is reality. What the telescopes actually found was next to nothing. The whole magnetic track theory was suddenly looking really shaky. But here's the really cool thing about science. Sometimes finding absolutely nothing
is the most important discovery you can make. And this is where finding nothing changes everything. The fact that there are no X-rays forces us to a startling conclusion. Either the magnetic cage is incredibly weak, way weaker than what we typically see in the galaxy, or Geminga just isn't producing the ultra-high energy particles we thought it was. Either way, our models are wrong. So let's just summarize the case here. We have confirmed a massive, totally bizarre gamma-ray halo, where particles are basically trapped. But the X-ray signature that should come from that trap is completely missing. And that clue has allowed us to narrow down the suspects, pointing to an environment around Geminga that is just radically different than anything we ever expected. Honestly, the case is still wide open. We have this phenomenon that defies our standard models, but we don't have the strong magnetic field we'd expect to be causing it. It really leaves us all wondering, is this ancient spinning star showing us the first signs of cosmic rules we haven't even written down yet?